Okay, problem number 1. Mr. Finn wanted to know how much money a typical student gets paid. He used the working students in his class as a sample and asked each of them how many dollars an hour they get paid. The results are shown on the graph to the right. What is the standard deviation of this sample? Class, how can I calculate the standard deviation from a frequency table? I'm waiting. Give me an answer. Well, I don't know if anybody answered or not, but we've learned how to take a frequency table and turn it into numbers. These numbers represent how much money students earned. And this tells us how many. So one person, $7 an hour. Let's see, we got 5 people that earned $8 an hour. We've got 6 people that earned $9 an hour. And so on. So I can translate a frequency table back into numbers again, a list of numbers. Now that I've got the numbers, how do I calculate the standard deviation that I'm looking for? Yeah, I'm just going to type these numbers into the calculator and use that to get my standard deviation. So just hit your data button. You know what, let's reset the calculator. Everybody hit second 0. We'll say yes. So there, we just cleared the calculator. Now, hit the data button, and we get here. So here's where we can start typing in the data. So there was 1 8, and let's see, I forgot. There were, wait, I said that wrong already. There was 1 7 and then 5 8s. So let me go back. There's 1 7 and then 5 8. So 1, 2, 3, 4, 5. And then there were 6 9s. 1, 2, 3, 4, 5, 6. And then there were 4 10s. 1, 2, 3, 4. And then there were 3 11s and 2 12s. 11, 11, 12, 12. Okay, so now I have all the data typed in. How do I find the standard deviation? If you look at the data button, you see the word stat above it. That's where I want to be. So I hit second data, and I come here. I want one variable statistics, so I just hit enter. I put my data in L1, so I'm good. I hit enter about 3 times. So here's where a bunch of information is. Now, that first one just tells me there were 21 numbers. The second one is the mean, you know, the average. Now, these next two, item 3 and 4, both of these are a kind of standard deviation. You can see they're close to each other. How do I know which one to use? All right, hopefully somebody in the room said the S1 is for sample standard deviation, and the sigma here is for population standard deviation. So look back at the problem. Am I going to use population standard deviation, or am I going to use sample standard deviation? Well, considering they tell us right here that this is a sample, then we are going to use sample standard deviation. So make sure you quote the S. So we will say 1.39. Well, I guess even still we would round to 1.40. Now I see that in this case those would have rounded to be the same thing, but a lot of times that won't be true. So you do have to be careful whether you're talking about sample or population. Sometimes the numbers are significantly different. All right, but anyway, the answer to this question is that sample standard deviation is 1.40. Okay, let's see what the next question is. So number 2. Imagine that the student who earns $7 an hour has his pay cut to $5 an hour. Assuming that all of the other students get paid the same amount as before, how will the mean, median, and standard deviation be affected? Okay, well, we should be able to answer about the mean and the standard deviation immediately without any calculations or anything. So we're saying, look, there was this one person that got paid $7 an hour, but he's not going to get paid $7 an hour anymore. He's going to get paid $5 an hour. So let's say this is $6 an hour, this is $5 an hour over here. So this guy in the data is going to move to the left. So I'm going to have a new one over here. Okay? So he changed from being 7 to now he's 5. So by making that change, let's talk about the mean. Do you think the mean is going to increase, decrease, or stay the same? Go ahead and hold up one finger for increase, 2 fingers for decrease. No, I changed my mind. Give me a thumbs up for increase, thumbs down for decrease, and hold up a fist if you feel like they will stay the same. Okay, hopefully everybody indicated that the mean is going to decrease.
Good morning, teacher.
We took a number and made it smaller. So the mean takes all of the numbers into account. You're adding up and you're dividing by the total. So if you make a number smaller, you will always be making the mean smaller. Now let's talk about the median. If we want to know whether the median is going to increase, decrease, or stay the same, we need to remember what the median represents. Who can tell me what the median represents? Go ahead and just blurt it out. Somebody probably said the middle number. The median represents the middle number if we had them all in a row. And we do have them all in a row. So the middle number, before we changed this 7 to a 5, the middle number was probably a 9. Now, so the question is, does changing this 7 to a 5 have any effect on the middle number? No, of course not. We're messing around with numbers on the edge of the distribution. We're not affecting the middle at all. All of these numbers in the middle area stay right where they are. The middle is still the middle. It's still probably 9. So just sort of using common sense, we know the median will stay the same. Moving numbers on the end just doesn't affect the middle number. Now, as far as the standard deviation, that should be obvious also. Do you guys remember what the standard deviation is supposed to represent? What does it tell you about the data? Okay, I hope you guys are actually responding to this and not just sitting there quietly. You'll get more out of it if you participate. Now, the standard deviation is supposed to tell you how spread apart the data is, or how close together the data is. So, if the data is more spread out, that's going to be a higher standard deviation. If the data is closer together, that will be a lower standard deviation. So in this case, what's going to happen to the standard deviation? If I make this change and the person who was making $7 an hour is now making $5 an hour, I want you to just take 5 seconds and decide, will the standard deviation increase, decrease, or stay the same? Just think silently for 5 seconds. Okay, give me a thumbs up if you think the standard deviation will increase. Give me a thumbs down if you think the standard deviation will decrease, and hold up a fist if you think the standard deviation will stay the same.
Good morning.
Okay, hopefully you can put your hands down. Hopefully everybody said that the standard deviation is going to increase, because by moving this over to a 5, I'm making the data more spread out than it was before. So that's going to increase the standard deviation. Wait, I forgot to circle this. The median stayed the same. Okay. Let's talk about number 3. Mr. Finn wanted to get a better idea of how many dollars an hour Roswell High School students get paid. So instead of just using one class, he used 3 of his classes as samples. The sample size in each case was 7, and the standard deviation of the sample means was 2. Predict the standard deviation of the entire population. Now this sounds complicated, but it really isn't. It's just that there's a formula that we used to use to do this. Probably you don't remember what the formula was, because it's just not the type of thing that we carry around in our heads. But let's put the formula back into our heads in time for the EOCT here. Now look, my children, here's the deal. Here's the key word that lets us know we're going to use a formula. Well, there's really 2 of them. When you see that they're mentioning the sample size, and then especially when you see something about, let's see, the standard deviation of the sample means. Standard deviation of the sample means. That's a trigger to let you know that we're going to need the following formula. This is the formula that involves standard deviation of the sample means. And look right here. This is the standard deviation of the sample mean. Look at this as one variable. You know this represents the standard deviation, and this represents the sample mean. So together this means standard deviation of the sample mean. So if this is the standard deviation of the sample means, this variable n represents the sample size. Okay, this one over here represents the standard deviation of the population. Okay? So all we have to do is substitute in the numbers that we're given. So let's read through the problem and find which 2 of these 3 variables were given. Then we'll be able to solve for the other one. So it says, let's see, he used 3 of his classes as samples. The sample size in each case was 7. So they're giving us the sample size is 7. That's n. Okay, that tells us that n is 7. So I'm going to go ahead and start building this formula right now. So we have the square root of the sample size, so that's going to be like right here, the square root of 7. Let's keep reading. They say the standard deviation of the sample means was 2. Okay, so they gave us the standard deviation of the sample means. that goes right here. So that's 2. I'll just put that right here. Now, we're supposed to predict or figure out the standard deviation of the entire population. Okay, so that's another one of our variables. But we're not given the population, so that's the thing that we are trying to find. So I'll just leave that as the variable. Okay? So really, this is the answer right here, 2 radical 7. It says give an exact answer, no decimals. So this would be it. The standard deviation of the population would be 2 radical 7. Obviously, if I wanted a decimal, I could put this in my calculator and find a decimal. All right. During the holidays, Mr. Finn ordered several gifts from Amazon.com. The price per gift was, the mean price per gift was $42.50 with a standard deviation of $3.50. If he wants items wrapped, it's going to cost an extra $2.50 per gift. If he has everything wrapped, what will be the mean cost of each item? What will be the standard deviation? What will the standard deviation be? Okay? Now, if he has to pay extra for each item, is the mean cost going to go up? Is it going to stay the same? What's going to happen to the mean cost if he has to pay for wrapping everything? It's going to go up, right? Since he's paying the same increase on everything, how much is the mean price going to go up? $2.50. It's going to go up exactly the amount that he's paying for the wrapping. So if he pays an extra $2.50 per gift, everything's going up by $2.50. So the mean itself should go up by $2.50. So if the mean was $42.50, okay, the new mean should be $42.50 plus $2.50. What's that going to be? That's going to be $45. Okay? So that will be the mean price if he gets everything wrapped, $45. Everything went up by $2.50. Now, let's talk standard deviation. Show me on your thumbs real quick. He's paying an extra $2.50 for every gift. Give me a thumbs up if you think that will cause the standard deviation to increase. Give me a thumbs down if you think it'll decrease. And hold up a fist if you think the standard deviation will stay the same. Everybody show me your vote real quick. Standard deviation, increase, decrease, or stay the same? Okay, put your hands down. It looked like everybody got it. The standard deviation is going to just stay the same. All of the prices went up by the same amount. So are the prices spreading out or getting close together? No, they're the same spread apart. They're all moving together. So that's why the standard deviation will stay the same. So what will the standard deviation be specifically? It will be $3.50 because that's what it was before. And it won't change because everything moves together on that one. Okay? Number 5. Mr. Finn coaches the JV basketball team. His team has a mean height of 71 with a standard deviation of 2 inches. Okay? That means most of the kids are going to be, see if I add 2, subtract 2, most of the kids are going to be between like 73 inches and 69 inches, somewhere in there, 73 to 69. The majority of the kids will be in that range. What if a new student joins the team 77 inches tall? That's significantly taller than the vast majority of all the other kids. Maybe taller than any other kid. Okay, so he's sort of an outlier, right? On the high side. So by adding in this tall kid, show me on your thumbs one more time. What do you think is going to happen to the mean if I add in this outlier of 77? Just flash them at me. Thumbs up for increase, thumbs down for decrease, fist for stay the same. Okay, put your hands down. Yeah, everybody knew that one. If you add in an extra tall person, that's going to increase the mean. Now, show me on your thumbs what's going to happen to the standard deviation if I add in this extra tall person on the end like this. Thumbs up for increase, thumbs down for decrease, fist for stay the same. Okay, you guys are all correct. Can somebody jump in and tell me why you're saying the standard deviation will increase as well? Why?
Spreading out.
Because it's spreading out more. If you have most of the people in a certain area, you know, between between 71 and maybe up on this end you have 73, 69. Most of your kids are in this zone. If you have this one guy way over here at 77, that's causing your data to spread out. They're more spread out. That's why the standard deviation will be increased. Okay? Look at number 6. See if you can figure out what my strategy is going to be as I read this. In Central Africa, the women give birth to a mean of 5 children during their lives, with a standard deviation of 2 children. If you look at 11 samples, each with a sample size of 6, predict the standard deviation of the sample means. What do you think our strategy is going to be, you guys? Anybody? Miss Street says we're going to use that formula again. Remember? And again, these are the triggers that should remind you to use that formula from before. When it talks about sample size, that's in the formula. When they talk about standard deviation of sample means, that's one of the variables in the formula. Do they talk about the population? Well, they mention the word population. So it's all about using the formula. So again, the formula was this. The standard deviation of the population should equal the standard deviation of the sample means times the square root of the sample size. Know that formula, please. Let's see what we're given. Say again? What other formula? It's the same formula. I don't want to confuse people by showing 2 formulas. It's really the same formula. It's easy just because there's only one to know in your head at a time, and all you got to do is divide. Okay? So let's see what we're given. We're given that the sample size is 6, so that's our n. Let's see. Predict the standard deviation of the sample means. That means we don't know the standard deviation of the sample means. That's our variable. That means we must be given the standard deviation of the population. What's the standard deviation of the population?
11.
It says 11 samples. That's not a standard deviation. It's 2, okay? See over here where it says standard deviation of 2 children. That's the population they're talking about. Standard deviation of 2 children in all of Africa. That's the population, okay? So this formula becomes 2, because that's the standard deviation of the population, equals the standard deviation of the sample means, that's what we're looking for, times the square root of 6. Notice we don't use the 11, and we don't use the 5. So these problems have plenty of distractors, extra numbers that we don't need. So you have to be careful and really think about which variables are the right ones to use. How will I solve this and get the standard deviation of the sample means alone? Yeah, we simply divide by the radical 6, okay? Just divide by radical 6. So if I do that, divide by radical 6, divide by radical 6, put this in your calculator, 2 over radical 6. Okay. Does it give you a radical at first, or does it go straight to a decimal? Root 6 over 3. So if I guess it does say give 2 decimal places right there. Just in case on the EOCT it's exact, just understand that you could get that. And I heard that that was root 6 over 3, which equals, now give me the decimal again. 0.82. 0.82. Okay, this time they asked for the decimal, so there you go. So watch out for the formula, you guys. Okay, almost done. Now, it's been a while since we looked at this thing. Remember, this was more stuff that we had to memorize. I think it'll come back to you. You guys used to know this really, really well. So just, over the weekend, take a few minutes to study over this and make sure you remember all of these percentages. Both the percentages that are in between all these lines and the big ones here at the bottom. 1 standard deviation in either direction, 68%. 2 of them is 95%. 3 of them is 99.7. So let's just jump right in, because I think you guys remember how to do this. So we're supposed to sketch the normal curve. So here's how you sketch a normal curve. Let's see. So just start by drawing yourself a bell curve, right? So just as best you can, draw yourself some sort of a nice little bell shape. Okay? And you see I'm not the greatest drawer in the world, so just do your best on that. Now, when you do the lines, this is what I recommend. We're going to have one line right down the middle. That's your mean. Now, if I were you, I would scoot over close to the end. Not all the way at the end, but close to the end, and put a line. I would do that on the other side too. Go close to the end and put a line. Now, how many lines go between these two? 2. 2 lines will go between the 2 that I put, okay? So that's why I always start with these 2, and then I just try to space out my other 2 lines as best I can. So then put 2 lines in between, put 2 lines in between. Space them out as best you can. Okay, that's how you set up for this thing. Now, in the middle goes the mean. What's the mean for this problem? 70. So you put 70 in the middle. Now, how do I get the other numbers? Yes, you take that standard deviation and you add it going to the right, or you subtract it as you go to the left. So, adding 6, give me the numbers going to the right. 76, 82, and 88. Whoops, 88 I said. Okay, please give me the numbers going to the left. 64, 58, and 52. Does everyone understand where these numbers are coming from? Okay. Now, remember the percentages. I like to just put the percentages right in there to help me remember what's going on. So I'm going to do that right now. So remember, this is 34%. What's this one? 13.5. This one, 2.35. And finally, right, 0.15. Right? And it's the same going the other way. 34, 13.5, 2.35, and Okay. So, part B. What percent of the scores are between 52 and 88? Okay, 52 and 88 are here and here. Well, this is one of those main three, correct? How many standard deviations out did I have to go to do this? Let's see, 1, 2, 3 standard deviations in both directions. So that was the which percent again? That's our 99.7. So that one was 99.7%. What interval contains 68% of the data? Correct. The 68% is one standard deviation in both directions. So that's interval is, and you can write it this way, 64 to 76. Or you can write it in words, 64 to 76 with words. What percent of the test scores are greater than 82? Yes. Let me get rid of some of this. Greater than 82. So we're talking about being 82 or greater. From here to here, you added up these two, that's 2.5%. Okay? Stop me if you have any questions about where these numbers are coming from. What percent of test scores are between 58 and 76? Okay. 58 and 76. I heard people saying 81.5%. Is that what you said? Okay. How did you get that? Sure. You just added up these numbers, right? You added up these percentages. And that's how you got 81.5%. Now, be careful. When we first learned this, some people had trouble with questions that were worded like F. So watch this very carefully. How low are the lowest 2.5% of the test scores? Okay. The lowest 2.5%. Obviously, I'm looking at the bottom side of the picture if I'm talking about the lowest 2.5%. But how many zones should I be looking at? How many of these zones am I including for 2.5%? I heard 2 zones, right? Can everybody see that these 2 zones are the lowest 2.5%? So, how do I describe those numbers? Do I say, let's see, how low are the lowest 2.5%? Do I say that they are below 52? Are they between 52 and 58? What do I say?
58 and
58, right. If I want to say it in words, I would say less than 58 or below 58, something like that. If I said it in words, I would say it like that, below 58 or less than 58. If you want to say it as an interval, like we did before, below 58, you could write it as negative infinity to 58. I would accept either one of those. Obviously, on a multiple choice test, they could give it to you either way, so you'd be able to recognize it in either form. How high are the highest 16%? You always have to go from lowest to greatest, so it would have to be negative infinity to 58 in that order. Okay? So they said the highest 16%. When I'm talking about the 16%, how many zones am I talking about? 3 zones. It takes 3 zones to make 16%. So the top 3 zones will be the top 16%. So tell me the answer. What will I say? Okay? I heard you say that it's starting right here at 76. So you're going to say more than 76 if you're going to say it in words. Okay, I lost my marker. Okay, so you could say more than 76. How would I put it if I wanted to put it as an interval? I could write 76 to infinity. All right, is that the end of the worksheet? Yeah. Wow, our last worksheet. Well, I mean, you got to do the one at home, but... Oh, why am I like printing it or something?